Now, having gone through the sines, cosines, and the tangents of angles with some examples, we are continuing now by looking at rules of sines. Now, let's have a circle divided into 4 equal parts called quadrant, which shows as this. We have at the first quadrant where all the sine, the tan, and cos are positive. Then we have the second quadrant. In that second quadrant, this angle is between the 90 and 180, and only the sines are negative. That is, sin theta is greater than 0. All other, the tan, the cos, are negative. In the third quadrant, where we have tan in this case, tan is greater than 0, sine will be negative, and also cos will be negative. And also in the fourth quadrant, in this case, we have only the cos that is positive, that is, cos theta is greater than 0, while the sine and tan are negatives. So these are the summary of the table of the values. We have the theta range from the 0 degree to 360 degree. We have tan theta, cos theta, tan theta. As sin theta equals to 0, as sin theta equals to 0, in degree we have 0, 30, 1/2. At 45 degree, 1/2. At 60 degree, we have root 3/2. And at 90, we have 1. 180 degree, we have 0. 27 degree, we have -1. And at 360, we have 0. Cos also, we have in that case. And the tan, at tan 0, range to 360 degree. Now let's look at the example in this case. Without using any table, we can find the following: the sine 135 degree and cos 240 degrees. Now let's take this solution one after the other. A, sine 135 degree. This is within the second quadrant, and in that second quadrant, our sine is positive. This will give us sine into 180 degrees minus 135 degrees. This will be equals to sine 45 degrees. And as I earlier discussed, sine 45 degree equals 1/2. Now, B part, cos 240 degree. Cos is within the fourth quadrant. Which gives positive. But in this case, we have cos 240 degrees. And 240 degrees falls within the third quadrant. And in that third quadrant, cos is negative. In that third quadrant, only tan gives positive, and this implies that this will give cos 180 degree plus 160. This will give, in that case, remember that cos is 160, cos is negative, and this will give us minus cos 60 degrees, and cos 60 degree will give us minus 1/2. Now, in these sections, we want to show how degrees and the radians, how degrees are being converted to the radians, and also radian to degrees. Now let's look at this angle subtended at the center of a circle by an arc in a length to a radius of a circle, which is called radian. Now remember that theta will be equal to length of arc AB over radius times the circumference of the circle, which is 2 pi r. Note that the complete rotation of the circle is 360 degrees, and this is, we have 2 pi r all over r, which is equal to 2 pi radians, and in radians this will give us 360 degrees. Now 2 pi radians, you said is 360. Now let's look at some examples. Now we want to convert the following angles degrees to the radians. We want to look at 0 degrees, 30 degrees, and 60 degrees. Now A, 0 degrees, now we have pi over 180 times 0, this will give us 0. B, pi over 180 times 30, this will obviously give us pi over 6. By the time you count to 30 here, 30 in 180 will give us 6. And the third, which is C, pi over 180 times 60, and likewise 60, 1, then 60 in 180 give us 3, which is finally we have pi over 3. Now we have come to the end of today's section. So next class, our section will be the trigonometric identity. Thank you. We meet next class. Thanks for listening.